All right. Good morning, good afternoon, and good evening, everyone.
Hello, hello everyone, wherever you happen to be.
All right. Yaroslav, do you want to kick it off? You want me to kick it off?
I would be grateful if you could kick it off. It happens to be in the middle of the night for me.
Okay. No problems. I'm just glad to have you online. Okay, so let me just kick it off. Okay, next slide. Okay, so this is an official interim. So the rules of the IETF still apply. So note the note well. Hopefully all of you are familiar with it. So I'm not going to read to you with respect to the contributions and the participation. Just make sure we treat everyone with respect and we stay on point to the work that we are chartered to do. So with that, we have, even though we have two presentations, I believe we do have a full agenda because from the charter, we need to make sure we understand the use cases and agree to them so that we can start reviewing the proposed specifications and then make sure that we get reviews and comments before we can do call for adoptions on those as well. So agenda bash, any comments, questions on the current agenda? Going once, going twice. All right, Yonut, you are up. Did you want me to share the slides or do you want to take the helm?
If you could share the slides, that would be great. Thank you.
Okay. There you go.
Okay, thank you very much.
Oh, hold on. I forgot one order of business. It would be great if we can have at least one note taker to ease the chair's jobs of the note taking, even though this is being recorded. Thanks, Usama. All right, we can move forward. We have Usama helping with the notes.
Sure. Oh, I forgot to ask. Am I driving the slides or should I ask for slide changes?
It's up to you.
Okay. I'll probably just ask you if that's okay.
Okay, because I was going to say I can give you control, but I can drive them. That's fine.
Okay. Okay, so thanks for joining the presentation. So I'll be giving brief updates for the use cases and properties draft. So the updates since the IETF 124. Just a note that I am dealing with a cough, so hopefully that's not going to be affecting me, but apologies in advance. And also, I'd prefer if we have only clarifications and clarifying questions throughout the presentation, and then we'll leave more substantial discussion for afterwards. Next slide, please.
Oops, sorry.
Okay, thanks. So for background, I just wanted to set the scene for where we left off at 1 to 4. So this draft is essentially trying to condense a set of reference use cases of interest for the SEAT working group. We're trying to find out where we would want to have secure establishment and remote attestation working together. And also, since this is a part of the charter, we're trying to fulfill that requirement. And the second part of the draft, as the name implies, is a set of properties that should help anyone who's working on actually designing protocols as part of this working group have some sort of maybe guardrails or flags to make the design more coherent and pinpoint the right directions. Okay, next slide, please. So as a starting point, at the previous meeting, we already had a number of use cases and properties defined in the draft. On the use cases side, we had 3 high-level use case categories. And these were confidential data collaboration, secure provisioning and high assurance operations, and network infrastructure integrity. And each one had basically 2 use cases underneath. So overall, we had data clean rooms, secure multi-party computation, runtime secret provisioning, and high assurance command execution, and the attestation of network functions, also securing control and management planes. On the properties side, we've defined a number of properties. So those were cryptographic binding to communication channel, cryptographic binding to machine identifier, attestation credential freshness, negotiation capability discovery, attestation model flexibility, interaction with peer authentication, credential lifecycle management, which has since been renamed and slightly reconfigured into runtime attestation, and also privacy preservation and performance and efficiency. So this is what where we started, where we left off at 1 to 4. Next slide. And since then, we've mostly been focusing on new use cases, or use cases in general. And we have 3 high-level use cases that we've added. First one is operation-triggered attestation for dynamic high-impact application operations. And this is where we want highly dynamic applications to perform sensitive actions, for example, a payment on our behalf. An example here would be something like an AI agent whose state or configuration changes frequently, that would want to perform some sort of sensitive action. So again, like a payment on our behalf. Second use case is attestation of a certificate's private key. So let's say you have a key and a certificate for it, and during the, let's say, TLS handshake, you want to provide some guarantees, some fresh guarantees regarding the security properties of that private key. So, for example, to prove that the key is not exportable or that it's stored in some secure environment. The last use case we've added concerns platform-to-platform communication, and in particular to enable workload migration over some attested machine-to-machine secure channel. And an example here would be something like a cloud provider wishing to migrate confidential workloads from one platform that they want to, let's say, turn off or do some maintenance on, but they don't want to lose uptime for the services hosted there. So they're going to do migration to a different confidential platform. And we'd want that to be over an attested channel. Just a note there that we're not particularly interested in the security properties of how this whole migration would happen. We're just interested in making the case that remote attestation with secure channel would be required there. Next slide, please. In parallel with the new use cases, we've also been working with Yuning Zhang as the main author of this, working on some analysis for the use cases that we've gathered. So Yuning has been looking at basically at different lenses that we can use to assess the use cases that we've been gathering. And this will help us essentially both improve the draft, but also have a better understanding of the various properties that we would want to either emphasize or just have as drivers for our designs. And so far, she's identified 2 lenses. The first one is for roles, or let's say remote attestation roles. So for each use case, trying to define who the attester and who the relying parties are, whether it's the client or the server for the secure channel, or whether this is something mutual. The second lens covers attestation timing, at least relative to when the connection is established. So this would cover things like whether the remote attestation is required when that connection is initially established, whether it's needed at runtime, including credential refresh, or both. So at runtime, it would mean something like during the lifetime of the connection, whether we want to perform a new remote attestation step. And these were inferred from the freshness dynamics that are described by the use cases. So as I've mentioned, we're hoping to use this to clarify and to enhance the draft in the long term. Unfortunately, I haven't provided a link here, but I will provide a link to where this analysis is hosted because it's currently not in the draft. It's under a GitHub issue, but I'll try to update the slides and provide a link after my presentation. Next slide, please. So to go over the two analysis. So I've essentially displayed them as tables. On the left-hand side, you can see the use cases that I presented earlier. In the middle, we have the role, so who the attester would be in that secret channel. And then on the right-hand side, a very brief rationale. On the GitHub issue that I mentioned, the rationale is further expanded, but just for briefness, I've added a few words here. So just to look at a couple of examples, I won't go through all of these. But for example, for runtime secret provisioning, we expect workload or the device to connect to a secret manager and to request some secrets or cryptographic material, things like that. So the tester would essentially act as a client in the secure channel. So the workload would connect to the secret manager as a client and need to attest itself before it gets the secrets. On the other hand, for high assurance command execution, an operator would connect to some server and issue at various times some commands for which it requires a higher level of assurance. So then the server would need to provide some attestation credentials. So I'm not going to cover all of these here, but we can have a deeper discussion afterwards if you're interested in any of the particular use cases. Next slide, please. So the second lens was attestation timing. Again, on the left-hand side, use case. In the middle now we have basically checkboxes for whether attestation is required at the beginning, during the lifetime of the connection, or both. And again, looking at, for example, runtime secret provisioning. Let's say a device is connecting to a secret manager. It would need to obviously prove its state at the beginning of the connection so that it gets whatever secrets it needs to get. But then if it's looking to have an ongoing secret management support from the secret manager, then it would probably need to have ongoing reattestations or refresh of the credentials. On the high assurance command execution side, for example, we'd expect the connection to be there in place, and then whenever a command needs to be executed, then we'd have fresh credentials being generated to provide higher assurance. Next slide, please. So just to wrap up, we have a few open questions for the working group. Again, focusing mostly on the use cases. So which of the use cases do you think are most relevant, and whether there are any use cases that we've missed? So which one should we keep most in mind when we're thinking about what solutions are best suited for the working group? In terms of the analysis, are there other lenses that could help us when designing solutions, other ways to look at the various use cases and ways to extract information from the use cases that we've collected? And last but not least, how do we improve this document, and how do we move it towards adoption in the future? And that's me.
So Unit, I haven't been able to look at the Git to see who's been making comments there, but I mean, officially, as chairs here, we should ask the question, who has reviewed the document? I guess I need to start a poll, huh?
Let me take care of this.
Thanks, Yaroslav. So we're going to open up a poll to ask the question of who's actually reviewed it. And prefer for it not to be the authors, of which we have quite a few.
Well, sometimes authors are very surprised with contents of their own document.
Yes, but I would not expect the author. I mean, I expect the authors to have read their own content, is what I'm saying. So discounting the authors is what I'm trying to say. So currently, I think there's 7, 1, 2, 3,
Yeah, look,
4, 5, 6, 7.
so the poll seems to be concluded. We have 6 yes, 8 no, and 0 of no opinion.
Well, they shouldn't have a no opinion. They've either read it or not.
Yeah, so we have 0, so which is a good thing.
Yeah. I don't know
but-
that I've seen a lot of feedback on the mail list, I think is my question and concern, right? So let's open up the question here to see, as Yonu had asked, if those who are not authors, if they can comment whether these are the appropriate use cases. If they're not, if you can comment on that, if they're missing ones, just opening up the floor for general feedback on the draft. I can't tell if anybody's got their hands up.
Oh, Paul.
Paul.
Let's see, does this sound work? Okay, great. Yeah, so as an individual, so I did not read the draft, my apologies, but based on the presentation, I'm wondering whether the use cases are maybe focusing too much about the use cases in the industries versus the use cases that require different properties and different protocol work. And so normally I think what we try to do in the IETF is like list the different use cases as in from the protocol point of view, and then list examples of those specific use cases. And I think maybe here what's happening is that there's a lot of industry pointers of what people are using, and then mapping it to the protocol doesn't really happen because a lot of them seem to be the same use case from a protocol point of view. So I'm not sure if use case, if the working group has a agreed upon definition of what we mean when we set use cases.
True. I think that's maybe something that we haven't touched upon too much. I think, at least my personal opinion, is that one of the reasons maybe that we focused quite a lot on the industry use cases is that I think we probably felt a need to justify the need to have this work done in the first place and to have the working group, I guess. And yeah, the focus was on, okay, where would this be adopted? Where would this be deployed? Who would need this?
So I think, having been in different, especially in the rats, since there's a bridge here to rats, we did do both of the assessments to tease out the requirements. So, Paul, not to put words in your mouth, but basically, I think from your request and what I've seen with other working groups is the current draft is putting the applicability to industry, but for us, from the technical aspects of what we need to embody in the charter, it's the assessment of the TLS protocol and the mechanics of that. Would that be fair?
Yeah, I think so. With the exception of, like, since I didn't read the draft, I cannot make any statements on the draft. I'm basing it on the slides only. But yes.
Yeah. Well, so the draft. So I did read the draft, and the flow does put the applicability to industry vis-a-vis the use cases, but then at the end it outlines the requirements. So to me, it felt that it was both the use cases that's driving the set of requirements. I think what's missing, and I think you're highlighting, and you commented here too on the chat, is the general assessment to where in the life cycle of a TLS tunnel is it appropriate that an attestation is required? Which is why I was saying it goes into the mechanics and the assessment of, pre-post handshake or during the initial handshake.
Okay, that's certainly something that we can try to take on and remodel the drafts, at least obviously the use cases side of it.
Okay. Well, I think you have good content, because I think, if I recall from the Both days, people wanted to understand, who would use it, applicability. But again, when it comes to the requirements of what we do within the protocol itself, right, and the required, I'll say, enhancements, I think that needs to come out more clear.
Okay, yeah, no, taken.
Yeah. And we certainly need more reviews. So authors are important, but also readers are important. So to answer the last question, to make document fit for adoption, we need more reviews on the list.
Okay.
Usama is in the queue. Usama?
Yeah, hello. Do you hear me?
Yes.
Okay, thanks. Yeah, so to address Paul's comment, I think the draft that I have had a good bit of reviews. There the focus is hopefully what Paul was mentioning, that it's heading toward the protocol analysis rather than the use case analysis. So as to say, it will take use cases as in, but it's focusing really on pre, intra, and post, kind of doing the analysis of what are the different parameters which we need to consider for protocol design, and then map it over or include some use cases, or maybe import within that draft, or I don't know how that would proceed, but that is at least my understanding, that it's going towards more of the protocol analysis and keep the industrial use cases as a backup, that where it is mapping and how it is going to be used, what are the trade-offs that we need to make for each design, and so on.
So, Usama, I think that's slightly different. Your analysis will be valuable once we understand what the requirements are. So if I heard correctly, for a couple of the use cases, they wanted to be able to react when there's a posture change. So that's definitely not a pre, that's a post, or right. So the use cases is more to help us drive the requirements. And I think your draft will get us to the trade-offs, you know, vis-a-vis performance, security, and all of the other things as we head towards the proposals. Hopefully that makes sense. Didu, were you trying to get on the queue?
Hello, can you hear me?
We can.
Yeah.
Hey, yes, that makes sense. I think as one of the authors of the draft, right? I think adding use cases and requirements, right? I think that will, if many of these use cases may have common requirements, so I think we will try to add requirements and then post a new version.
Sounds good. You're on the queue?
Yes, yeah. So does this misstatement that's being done with respect to intra versus post that I think needs to be clarified? The difference between the two protocols, well, the two proposals that are on the table are in the layer in the protocol stack that each one is being integrated into, rather than in does it happen in the start and then does it happen later on or periodically. Both of them happen both in the start and later on or periodically. Intra-handshake is integrated in one layer of the stack. Post-handshake is integrated at a different layer in the stack.
Osama, do you?
Yeah, sure. I want to follow up on this, Yaron. I don't agree with that. I think it's implementer's choice where to kind of implement intra and post. It's not necessarily about where you. I mean, the distinction that you're trying to make, I think I disagree with that, kind of with the layers. So the thing is that at what point in time you actually sign the signatures compared to the point in time where the TLS handshake was happening. So intra and post handshake, as per all the literature that exists, and they have gone through good conferences, of course. So I'm not the only one. It's also the same definition that exists in the global platform. So I can put the link in the chat. So it's not only me who is saying this, so it's in other standardization bodies as well. And the distinction that is there is not about the layers at all. It's the point in time really when you actually do it. If you do these signatures within the TLS handshake, it's intra. And if you do it afterwards, it's post. And it has nothing to do at all with which layer you are talking about. So you could have, like, as in one of the emails Yaroslav proposed, like we have a shim layer kind of between the application layer and the TLS layer. So your definition will break there. It's neither in the, let's say, the TLS stack, it's nor in the application layer. So it's in between somewhere. So I think a proper, precise definition in this case, as per literature and industry, is that at what point in time relative to the handshake you do these signatures. And the important point that I want to highlight here from security perspective is that remote attestation provides you guarantees about only the time when these claims were signed. That's the cryptographic point in time that these claims get attested. And then you could have a time of check to time of use attack. So that's relative from that perspective. Whichever layer you implement, that doesn't matter. That timing is the most important in my perspective.
I joined the queue as individual contributor and attestation enthusiast. So from my perspective, both of these aspects are important when attestation happens in terms of life cycle of the connection, but also on which layer the messages are embedded and how is it conveyed through sophisticated APIs of modern protocols. And as Paul mentioned in the chat, another important property here is scalability. So if you have a server serving lots of clients, as Paul says, it's difficult for it will be to do from scratch attestation from all the clients. So we don't necessarily for all use cases require perfect security properties. There are different trade-offs that we might have to do, at least on the implementer side. And it feels to me that these questions should be explored in the use cases document. So that is not only where the attestation itself is applicable, but what sorts of timing and scalability requirements and what kind of security properties are required for those core use cases.
So, Dido, you must be in transit. You're trying to get in the queue again? Go ahead.
Yeah, so yeah, it's late in the night for me, so sorry for that. If you're talking about security properties, I think it's not just about the time when the attestation is triggered. I think it's also about which layer it is triggered and what protocols are being used beyond TLS, right? I mean, for instance, if you look at the post handshake one, it pretty much relies on application changes. So for some of these use cases, we will try to find out what are the applications being used and what does it mean to change these applications, right? So I think changing, for instance, if it's just related to changing TLS versus, hey, if you're doing some mechanism where you have to do changes to both the TLS stack and then you have to do changes to the application, then listing that would actually give us a holistic picture on what does it mean to deploy this and the level of involvement that would be required to deploy a complete solutions for these use cases would give a complete picture, I believe.
Well, I think that's it doesn't necessarily needs the changes in the application itself. So one has to really distinguish between the changes in the application versus at the application layer versus at some layer between TLS and the application layer. The reason I'm making this distinction is that it shouldn't be interpreted like that the post handshake is necessarily changing the application itself. That's quite wrong. So as I have already pointed out, like you could do it between the two layers and you could have a runtime which is actually not changing the application business logic at all. And that runtime is taking care of everything, which is which makes no changes to the application at all. So that's, I think, an important distinction to make. When you say application changes, it should be really clear that it's whether it's application layer, whether the application itself versus some layer in between.
Okay, so with that, we need to move on. I was giving the use cases draft more time because that's definitely in our charter to make sure that we're moving forward. So for the authors, I think you've gotten some of the feedback. For lack of reviews on the mail list, I think you've gotten sufficient. If not, you can go through the notes or reach out to me, but it sounds like the different perspectives for where it's appropriate and the use where meaning pre-post, intra versus post, as well as in the messaging layers would be important to articulate in the use cases as well, because I think that will help tease out the requirements as we go towards adoption of work. Okay?
Okay, thank you.
Yep. All right. Thanks, Yonu. Okay, Yaron, do you want me to give you control? Do you want me
Yes, please do.
Okay, where are you? Oh, I guess I need to bring up the slides.
Absolutely.
Give me 1 second. All right, I think you're on now.
I am on. I don't think my camera is collaborating, so we'll stop that. Okay, thank you, Nancy. So I think everybody on the call is aware we submitted a draft called early attestation. We're basically at 0, we published a small correction based on feedback we got on the list. Should have been 01, actually it's 02, but it's really, if you've read 00, it's almost the same. It's a long presentation, and I would appreciate clarifying questions only until we get to the end. I will try to run as quickly as I can so that we have time for discussion at the end. I will not read out the agenda, but just jump into it. So our main motivation is the first bullet on this list, have the simplest possible integration with applications, and we will show it at a later slide exactly what this looks like to an application. But it's basically the application sees a plain vanilla TLS connection. Additional motivations were to make a minimal, not 0, but a minimal disruption, a minimal change to the TLS handshake into the TLS protocol as a protocol. So, for example, we don't need to discuss DTLS because DTLS is supported as is, and you can use our extension with DTLS if your stack does DTLS. We would like to support both client server, so client or server or attestation of both peers at the same time. Right now, the current draft does not support client-only attestation. We wanted to work with any attestation technology, both passport and background check models, and to work with any authentication, any supported TLS authentication method. However, right now we only support TLS authentication through certificates. Usama, only if this is a clarifying question, please.
Yeah, sure. It's only a clarifying question. So RFC 8446 says that TLS handshake protocol is a part of the TLS protocol. So I don't really understand why you have the two bullets separately. So to me, handshake protocol, like TLS handshake protocol, is a subset of TLS protocol. TLS protocol being a bigger set, which has TLS handshake, TLS record, TLS alert protocols. So
Okay,
I don't understand.
I don't think a semantic argument over the details of the slides would be useful now. The slide is not part of the draft. if you think this is misrepresenting what we're doing, that's fine.
I mean, my point was that I was trying to understand when you say minimal disruption. Let's assume I take TLS handshake for first. Adding a new message is something that's really even the TLS working group has not yet done, or at least I'm not aware of any draft specifications. Like PIC had some discussions, but there was none. So I'm trying to still understand what you mean by.
Osama, I don't think this is a clarifying question. Let's
Okay, sure.
let Yaron do the presentation, and then we'll dive into that.
Okay, sure. Thanks.
Once we're through the meat of this session.
From an application point of view, attestation is a configuration, not additional code. So you configure your TLS stack or you configure your TLS connection to require attestation as one of the peers. The application doesn't need to maintain state for that, to maintain a state machine and so forth. It just says, I want attestation or I require attestation for this particular connection. On the relying party side, this can be fully transparent if you configure essentially your trust anchors for evidence, or it can be a callback if you want to have more complicated logic or an external verifier. On the attester side, the implementation would probably be a callback rather than a configuration. As soon as the TLS connection is established, attestation is built in and available and guaranteed. And reattestation can be done fully transparently. So you can say, I want it every 3 hours, or you can, or the application can say something just happened. I want to do reattestation, so it can be driven by an API into the TLS stack. Elephant in the room. How does this stand with respect to the seat charter? So the charter says that the attested protocol will not modify the TLS protocol itself. It may define extensions, but will not add or modify, add or remove any existing protocol messages or modify the key schedule, and that the effort will not decrease the privacy or security properties of generic TLS, DTLS connections. We absolutely add an attestation message to TLS in this proposal. So we are not claiming to be within the charter as it is manifested by the first bullet I'm quoting. We add derivation of new secrets as a binder between the attestation and the TLS connection. So that's an addition to the key schedule, but no change to any of the secrets that the TLS protocol normally derives. And we claim and we have a whole section showing how we do not decrease any of the security properties of the TLS protocol. This is an example, one of the options or the combinations of early attestation. In this handshake, it's only the server that is attested. So what we see here is evidence request being negotiated by the client in the client hello, by the server in encrypted extensions. And then after this negotiation, there's one extra TLS message, in this case being sent by the server, and this is the new attestation message.
Yaron, we have a clarifying question from Paul.
Sorry, can you go back one slide with the diagram?
I'm trying to.
So I'm a little confused. So what is this new message you say? Because I see there's the...
Sorry.
There's a little delay, so don't press it twice because
Yeah.
it takes a few seconds for the presentation to catch up.
Well, in any case, the attestation message. So that's a new TLS message that we define.
I couldn't see it in the diagram. That's why I really want to see the diagram page. So
I wish I could.
So I see it's now
more
on the
than a
page.
few seconds delay.
So I see it now, but like, so the first is the client hello and the server hello.
So
is
within
that-
the client hello and server hello, there are extensions that negotiate what we're going to do. And then further down, you see an attestation in violet. That's a new message.
Oh, so there's a missing arrow there. There's a second message coming that way.
Yeah, I think
Okay.
your diagram may have gotten clipped, Yaron. We don't see a new purple message in the bottom.
No, there is a purple attestation there, but I thought that was all one message, but I think that those are two messages that the server sent. So I think there's an arrow to the left missing.
No, I think the attestation is the response to the evidence request on the left, and then the server sending an evidence request to the client, which we don't see the response to.
So
Anyway,
both evidence requests are okay. We will talk about the negotiation at a later slide. The attestation, the violet attestation, is a new message. Okay, so to enumerate exactly what it is we're adding negotiation extensions. There will be a slide about them. We're adding a new attestation message that consists of CMW structure, conceptual message wrapper being defined by the RATS working group, and that's basically a RATS evidence or a RATS attestation results. The TLS handshake does not depend on this message. So the message is passed as part of the TLS handshake, but it does not make any change to the TLS processing logic. And of course, it is signed just like any other TLS message in the finished messages on both sides. And the third and last thing we're adding to the TLS handshake is an attestation binder. We derive a new value within the TLS key schedule without changing any other derivations in the schedule. Negotiation. And I think that one I got wrong in the diagram above. So let's quickly go through the negotiation messages. We have 4 TLS extensions that we define: evidence proposal and evidence request, results proposal and results request. So evidence refers to the background check model, and results refers to the passport model and attestation results. And each of the peers can say what it requires and what it is able to provide, what it requires from the other peer and what it is able to provide. And so there can, in principle, be various combinations of these 4 extensions. We realize ourselves that this got more complicated than we'd like it to, and we are actively working to simplify the negotiation. The binder between the evidence. So the evidence is a signature of the posture of the TEE, but it also signs a binder that ties it to the TLS connection. The binder is derived from the TLS main secret, formerly known as master secret, the message transcript between client hello and server hello, which characterizes the specific TLS connection and provides randomness from both client and server, and the attester's public key. The binder includes the attester's public key, and that's the reason why the current version of the protocol is dependent on certificate verification. We are looking at ways to. We are looking at the question whether this can be eliminated, but right now we need the public key to ensure the security of the protocol. And of course, both the binder and the signature over the evidence must be verified by the peer for security of attestation. We have 7 minutes, so only if this is a very short question. Just one?
Yeah. So hi. Yeah. So actually, my question is just like you add the attester's public key also in the binder. So I wonder, is it only because that now the attestation is a new message, so you add it, or is there any other reasons that make you like decide to add the public key in the binder?
There are specific replay attacks that we had in mind as a reason for adding the public key here. So right now we believe the public key is actually needed for the security of the protocol. Pavel?
Hello, thank you for the presentation. I have a question about backward compatibility. As I understand, introducing a new TLS handshake message isn't backward compatible with existing TLS 1.3 implementation, because both sides should implement it to avoid handshake failure. Is it correct?
So just like any other extension, there's negotiation at the start of the protocol. If the client requires this extension to be implemented, it will get back a server hello without the extension, and so it will understand that the server does not implement it, and then it can decide whether a TLS session without attestation is acceptable or not. That's the normal negotiation of any extensions in TLS.
Okay, I see. Thank you. And another question about reattestation capability. Is it possible?
I haven't gotten to it yet. And I have 4 minutes to go. So I will move forward. And this is where we talk about reattestation. We are proposing to use the extended key update, which is a new exchange being discussed, a working group draft at the TLS working group. And to bind the new attestation into the new main secret that's negotiated by EKU. EKU can be initiated by either of the peers and happens completely at the TLS level. So again, it can be done periodically without any application involvement, or can be initiated by either of the peers. Osama, do you have a clarifying question?
Yeah, I hope it's a clarifying question. I had it on the last slide. So if you go back one slide, that was basically when you were claiming about this. Yeah. So client hello and server hello. So I presented at IETF 124 that having client hello and server hello is insufficient. So I just wanted to be sure that are you kind of disagreeing with my results of formal analysis, or?
So I don't think this is a clarifying question, but yes, I disagree with your results.
Okay. Could you share on the list? That would be great.
Osama, let's move on. Thank you.
Okay.
We're going to give you one minute because the chairs have an opinion on this as well. So we want to have at least a minute to wrap up. So
okay, so
we wanted to, yeah. Go ahead, you're on 1 minute.
Okay, so really quickly, there is an alternative being discussed right now among the editor team, where we replace the attestation message by an extension to the TLS certificate message, which would bring us within Charter, or much more within Charter than with the current proposal. This is still an open PR, and there are various alternatives or various variants of this alternative with respect to reattestation. So people are welcome to join this discussion. And so to summarize, we believe attested TLS can be done at the TLS layer, and we think this is the best way as far as applications are concerned. We propose to focus the discussion on whether intra-handshake or whether work at this level is the best thing for the use cases we have in mind, and less discussion of the Charter questions. And thank you.
Okay,
Excellent.
Yaroslav, go ahead.
Yes, thank you very much, Yaron, and thanks everyone who were asking questions and participating in this interim productively. Now, as was mentioned, this proposal is not currently compatible with SEET charter. And there are two, as far as I can tell, based on the discussions that I have seen, there are two big sticking points. One is the new attestation message. Adding new messages is a big deal. In TLS, there are many reasons for that. So I think for it to go forwards, it needs to be converted into extension if it's possible. And secondly, deriving new key from existing key schedule. Some see that still as a modification to the key schedule, which is a big deal. So I wonder if it's possible to, for example, maybe use early exporter secret or another existing secret that already exists in the key schedule, and maybe that would be acceptable compromise. This is not something that we have time to discuss now, so let us take this to the list. And again, thanks everybody for joining the interim, and thanks everyone for behaving so constructively.
Absolutely. Appreciate everyone. And Usama, if you can pass the notes to me, I'll compile them so we can post it as minutes.
Yeah, sure. I will improve them a little bit and then write to you. Thanks.
Okay, thanks. So Yaron, I like your motion of let's keep the discussion to whether there's interest on the intra handshake, and you've proposed ways to update your proposal to make it adhere to the charter. So I think that's the best way to move forward. All right. Thank you, everyone.
Thank you.
Thanks.